Hello, hello, hello. I think we should be live. So, we are preparing for sequel today. No games and anything. So, we'll be starting with the preparation for sequel. So, anything interview related, basics to advanced topics. We will be covering everything from the definition of SQL, relational databases, types of SQL queries, constraints, functions, UDFs, store procedures, triggers, normalization. What else do we have? I think we should just start with it. So, what is SQL? SQL is a structured query language which is a standard language used to interact with relational databases. And what can SQL do? Allows you to do allows you to create databases and tables, insert, update, and delete data from the tables, retrieve data using select, manage users and permissions using transactional queries like uh, grant and revoke, control uh, transactions with start transaction, commit, and rollback, and build logics. So store procedures, triggers, functions, etc. Let's just start with it. So select is a data query syntax. So select is used to retrieve data from a table in a database. So you can do like select name, salary from employees, where is used to filter data from the table that we are retrieving data from. So salary greater than 70,000. So when we select, we will be getting the name and salaries of the employees that have salary greater than 70,000. Simple. So what is a database? A database is an organized collection of data stored for easy access, retrieval, and management. Examples is employee information, customer orders, banking transactions, and other information like healthcare data, etc. What is RDBMS? RDBMS stands for Relational Database Management System. That is a system that stores data in tables with rows and columns. Tables are related using keys. Keys are primary key, foreign key. Primary key identifies each row in the table uniquely. And foreign key is a column or multiple column composite foreign key. Multiple columns, when you use multiple columns, it's composite foreign key, and if one column, it's a single foreign key. So it references columns from a different table. So we are building relationships between different tables using foreign keys. It can be cascaded so that when you update or delete data from a table, you can cascade it from the original table that is in the relationship. So examples of RDBMS are MySQL, PostgreSQL, SQL Server, Oracle. So I work as a business analyst. So I mostly work in SQL Server. Data models in RDBMS. There are multiple data models: hierarchical, network model, relational model, entity relationship. Hierarchical is parent-child tree structure like JSON. Network model is graph-like. We don't deal with that. Relation data model is important because we will be dealing with this today in a relational database management systems, that is MySQL or SQL Server Management System. Entity relationship model is entity relationship diagrams, how tables relate to each other. Say there's an employee table, there's manager table, there's payment table, and all these will be connected to each other with primary keys and foreign key constraints. What are types of SQL? Data types in SQL. So there are multiple data types in SQLs. So the main are numbers, text, date, and time. Boolean like true or false. Binary, which will be used to store images, videos, geographical data, and JSON XML. They control storage size, allow values, performance, and validation. So you can't insert like a string value in a number data type format. Numeric data types, integer types. So integer we have tiny int, small int, medium int, in MySQL integer or int, big int, very large integer, decimals like decimal and numeric, which will have precision and scale. These are mainly used to store money, prices, percentages, rates, quantities, etc. There's also floating types numeric values like float and real. We also had double with double precision, which has higher precision than float. Float or double are usually not used for money. We also have string data types. In string data types we have character, always stores exactly n characters. Variable length is varchar. Varchar is very common in databases that are used in companies, so this is very important. You will be using mainly varchar in most of the data you work with. Large text and text, varchar max, long text, medium text. These are used to store large amount of text data in columns like descriptions, comments, logs, etc. We also have date time data types. These are date stores in YYYYMMDD format, time stores time only, date plus time, times time, date plus time zone. Which time zone? Like UTC, IST, etc. Small date time and interval. These are not very important. Boolean we have true or false, 0 or 1. Binary, special, JSON, not so important file. For your interviews, you will not be dealing with these data types mostly. Unique identifier. Unique identifier gives unique ID to each row in a table. So spatial types. We will not go over this because that's not very important. You can go over this. We already discussed about this. So interview definition should be SQL data specify what kind of data column can store numbers, text, dates, binary, JSON or geographic data. They ensure data correctness, store efficiency and proper validation. So you can store text data into like a numeric or date time or any other data type that is not suitable for text data. There are certain types of SQL commands, So we have DDL, DML, DCL, TCL, and DQL. DDL is data definition language. Let's just get some definitions for these. DQL, DDL, DML, DCL, TCL in SQL. So there are five types of SQL queries. So DDL, DML, DCL, TCL, and DQL. Just wait for it to create some notes for us. So now we have some definitions with examples. Let's just save it. So DDL stands for data definition language. Data definition language commands are used to define and modify the structure of database objects like tables, views, indexes, and schemas. So create, alter, delete, truncate, and rename are some of the DDL commands. Create, alter, drop, and truncate. Delete is not a DDL command. Delete will come under data modification language, which we will see in a bit. So data manipulation language. Data manipulation language commands are used to manipulate the data stored inside tables. So it will include insert, update, delete, and select. So you can go through all this. This is very simple. Just go to the syntax and memorize all the syntax that is required. Data query language is used for querying and reading data from databases. So we will have select star. Star is for all. So all records from employees table, some columns from employee table. So we also have a filter here using where clause. We also have data control language which controls permissions and security in the database. So this will include grant and revoke. You can grant permissions to a certain user, Like in your organization, if there's an operational team which does not require any data manipulation, which do not require any manipulation on the databases, so you can grant or revoke permissions on those. So you can go like grant select and insert, grant select comma insert on employees to operations, or revoke like revoke, insert, update, alter, delete on employees from operations. Transactional control language manage transactions, group of SQL statements executed together. So it will be used for committing changes, undoing changes, setting save points. Common transactional control language commands are commit, rollback, save point, set transaction, etc. So you can begin transaction, update a certain table. If you want to go back, you can roll back. If you want to save the transaction, you can commit the transaction. So this will apply the durability property of transaction. So all the transactions in a database are permanent once they are saved. Once you commit the transaction, it will be permanently saved into the database. Okay, you can go through this table. Let's move it a little forward. So let's just quickly go through it. So data definition language used to create structure of the database. So create, alter, drop will come under data definition language. DML data manipulation language, we have insert, update, delete. DQL we have select. Data control language we have grant, revoke, commit. Grant and revoke. We only have grant and revoke, right? Yeah. And we have transactional control language. Transaction control language is used to manage transactions. We have commit, rollback, save point, set transactional, start transaction, etc. in transactional control language. Like we just discussed, we have durability, that is data is saved permanently once the transaction is committed into the database. So like durability, we have ACID properties in databases. So properties, ACID properties are the properties that guarantee reliable transactional in the database. So ACID stands for atomicity, consistency, isolation, and durability. Atomicity is all or nothing. So when you have a transaction, like you are modifying anything into a database, like inserting some transactions in a financial database. So when you execute it, either nothing will get executed or everything will get executed. Consistency is valid state after transaction. So in consistency, we have various constraints in the database that the database has to follow. So the transaction has to follow certain rules of the database. like the data types that are mentioned into the schema of the table, and various constraints such as primary key, foreign key, not null, uh, default, and unique. We will see that in some time. Isolation is transactions don't affect each other. So when multiple people are working on a transaction on a single table, so when two of the users are using the same table, there is isolation between the transactions. So when two of the when two of the users are using multiple the same table, so when two of the users are using the same table, they don't affect each other. So the second user will wait for the first transaction to complete, and then only the second user can use the table. Durability, as we discussed, is the data is saved permanently. So when you commit a transaction, the data is saved permanently and it will not be modified in any other way in case of any failure in the database. So here's an example of a transaction, begin transaction. Some accounts table is updated and balance is updated in the accounts table. Normalization, we will not discuss normalization today. So joins, SQL joins are used to join or combine multiple tables that relate to each other using a column that is common between multiple tables. So you can see here we have inner join, left join, right join, cross join, and full outer join. We also have self join. So here's an example of a inner join. So let's get the definition of all the joins. So inner join only takes common records from both the tables depending on the common column that you provide into the inner join. Uh, 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 Define inner join. Let's get some join study material for you. Just wait for a while for it to compute everything. Why are we only getting this much? This is good. Okay. So joins. So for joins, as I said, we have inner join, left join, right join, full outer join, cross join, and self join. So inner join returns only rows that match in both tables. Left join returns all rows from the left table and matching rows from the right. Right join is the opposite of left join, returns all rows from the right table and matching rows from the left. And full outer join returns all matching rows and all non-matching rows from both tables. So whenever a value doesn't match in any of the tables for left join, right join, and full outer join, it will return null as the value when joining the tables. So cross join, you will not be using this most of the time. So cross join returns a Cartesian product every row from A times every row from B. So if a table has 3 rows and another table has 4 rows, so 3 multiplied by 4 will be 12 rows. So a Cartesian product will return 12 rows in the result set of the Cartesian query. And we also have self join. Self join is used to join a table with itself. It will query. Self join joins a table to itself to find relationships within the same table. So if you have an employee table which also has managers, you can find which employees are reporting to which manager in the employee table. You can do that using self join. Correlated subquery. Why do we have directly correlated subquery instead of subquery? Okay, doesn't really matter. Let's just go through it. So correlated subquery is a subquery query within a query. So as you can see here in this example, we have employees table which in which we are using a subquery, which is a query within a query in the where clause. So when we have a problem like we want to find all the employees within a table which have salaries higher than the average salary of an employee. So you can do that using a subquery like mentioned here. We also have common table expressions which are used to commit readability in the query that you use. Instead of using a subquery, you can use a common table expression and you can give it an alias like here it is high salary. So you can use this high salary in a select query and query data from the common table expression in the analysis that you're doing. Or you can join this table with another table. So it is like a temporary table within your query. It only exists within the constraints of your query, of your current query, that is. So views. A view is a saved SQL query. So the syntax is create view, view name as, and your query. So a view is like a virtual table which does not have any schema into the database. It's just a saved query within the database. It's just like a saved query basically. Indexes. Indexes are used for performance optimization in the database. So indexes are like, for example, you have a book and you know you have an index in the book. So when you have an index, you can just go through the index and look at which topic you want to go to, and you can just directly go to the page of the topic that you want to study. So using indexes is similar. So you can apply an index on a ID column in a table. Like you can add employee ID as an index in a table. So when you use that index in a query, the queries will be faster. So we have clustered index, non-clustered index, composite, unique index, and full text index. I don't know about this full text index, what it is. Let's get some theory on indexes. IND. So let's just go through the syntax for index creation. So you can usually use idx underscore to name an index. You don't have to do it, but it's good practice to add idx so that we know that this particular database object is an index. Get some theory for indexes. Copy, save it. The content is getting larger, boys. Let's keep going. An index is a special data structure similar to an index in a book that helps to the database find rows faster without scanning the entire table. Indexes make select queries fast but slow down insert, update, and delete operations. Why do we use indexes? Without an index, database scans every row slow. With an index, database jumps directly to the matching row. Simple book analogy. Without index, you search every page to find a topic. With index, you go to the index page, directly jump to the correct page. This is the same example that I used to explain indexes. So basic syntax is this: create index on employees and the column name. Employees is the table name, name is the column name, and this is the index name. To drop an index, we have drop index and index name. So we have single column index, composite index, which will use multiple columns, unique index. Unique index is automatically created for primary key and unique key. Primary key and unique key are constraints in database. So primary key index, non-cluster index, let's see what is clustered and non-cluster index. What is clustered and non-clustered index? So the difference between cluster and non-cluster index is when you apply a cluster index on a column, it will restructure the table in a specific order of the index. For non-clustered index, the order in the physical table is not modified. So what is a cluster index? A cluster index defines the physical order of data inside a table. Think of it as a phone book sorted by last name. The data itself is arranged in this order. And non-cluster index does not change the physical order of the table. Instead, it creates separate structure like books index that points to the actual data row. Think of it as a dictionary in the back of a book. It points you to the page. Let's stop here and we will continue with function in SQL in the next stream. So I'm going to stop and we will start with functions in the next stream. Thank you. Bye bye. Yes.